Okay, so we're going to prove that the variance of x is equal to the expected value of x squared minus the expected value of x squared. All right, so let's go ahead and start this proof. So the variance of x, by definition, is equal to the expected value of x, so let me put a parenthesis, of x minus mu of x squared. All right, so the definition of expected value is the sum from 1 to n for however many are in the distribution of x, right? X of I minus mu of x squared times the probability that x is equal to x of I. Now, if we distribute this, right, this will be the sum from 1 to n of x of I squared minus 2 mu of x, x of I, plus mu of x squared. And all that is times the probability that x is equal to x of I. And now, this is equal to the sum from 1 to n of x of I squared times the probability that x is equal to x of I, right? I'm distributing, right? Minus 2 mu of x times x of I times the probability x is equal to x of I, and then plus mu of x squared times the probability that x is equal to x of I. All right, and now this whole thing is for this sum, but of course we can separate these sums, right? So this is equal to the sum from 1 to n of x of I squared times the probability that x is equal to x of I, minus 2 mu of x times the sum from 1 to n of x of I, probability x is equal to x of I, and then plus mu of x squared times the sum from 1 to n of the probability of x is equal to x of I. Because 2 times the mu of x is a constant, so we can take it out, right? Because all these terms will have that, so we just factor it out. And then mu squared is also a constant of all these terms, so we can factor that out, right? Of that sum. And this is equal to, so by definition, this is the expected value of x squared minus 2 mu of x. And then this here is the definition of expected value of x. And then plus mu of x squared. And then the sum from 1 to n of all the probabilities, we know for any distribution, the sum will be 1. Right? Now, I know mu of x is the same thing as the expected value of x. So this is equal to the expected value of x squared minus 2 times the expected value of x times the expected value of x, right? Because mu of x is the same thing as expected value of x, plus, and then this is the expected value of x squared, right? So now we have the expected value of x squared minus, so expected value of x times expected value of x is 2 times the expected value of x squared plus the expected value of x squared, and then minus 2 expected value of x squared plus expected value of x squared is just x squared minus the expected value of x squared. So we've proven using the definition of expected value, right, that the variance of x is equal to the expected value of x squared minus the expected value of x squared.